going on, guys? In this video we are going to see how to determine if a vector field on R3 is conservative or not using the curl. Now in order to do this one we are going to use this theorem. This theorem says if f is a vector field defined on all of R3 whose component functions have continuous partial derivatives and curl f is equal to 0, then f is conservative vector field. Now this is the main part. We have to see whether this curl is equal to 0. Now to find the curl, what we do is we cross product this del operator with vector field function. Now del is basically partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to c. Right? The easiest way to do the cross product is to put it in the matrix form and then we do the determinant. And if you remember, to find the determinant we just take ijk component and then let's see this through this example. Okay, but in order to do this one we have to know our pqr. P is the first term, like I component, that's going to be our P, and J component is going to be our Q, and then K component is going to be our R. Okay, now we have PQR and del operator and IJK. That's it. After that we just have to put it in the matrix form and then we do the cross product. Now let's go ahead and do that. Here we are going to have IJK components, IJK, and then we are going to have the del operator, that's going to be partial derivative with respect to x, partial derivative with respect to y, and then we are going to have partial derivative with respect to z. Okay, then our pqr, in our case p is 2xy, so let's put 2xy right here, and then we are going to have q, that's x square plus 2yz, x square plus 2yz, and then k component is like r is going to be y square, right? Y square. And if you remember, to find the determinant, what we do is we put plus minus plus right here, and then we take each term. Like if I take I will eliminate all the vertical and horizontal part of this one, so these are the four things that's going to remain. Then we do the AD minus BC. This is if it's A, B, C, D, then we do the AD minus BC. That's what we are going to do right here. Okay, here we have partial derivative with respect to y multiplied by y square. So we are taking the partial derivative of y square with respect to y. If you do that, you will get 2y, right? 2y. Then if you other side, partial derivative with respect to z of this function. And if you do that for this one, this x square is going to be 0 because this is a constant. And if you do that for 2y, this is going to be just plus 2y because z is going to be just 1. So we are going to have minus, because AD minus BC, since we have 2y here, we just subtract this one from this. And this is our first part. Now let's move to the next part, but before we do that we just have to put a minus sign in front, and then we take the j component. When we take the j component, we eliminate this vertical part and the horizontal part along with that j, and we are left with this one, this one, and this one, and this one. Okay, first we do the AD part. So if you multiply partial derivative with respect to x, y square, since we don't have any x variable here, this is going to be 0 because this is treated as constant, so this is going to be just 0. So here we are going to have 0 right here, and if you do the other side, here we don't have any z variable, right? So this is also going to be 0. So 0 minus 0, that doesn't do anything. Now let's go to the next one. The next one, we are going to take the k component. Like if we take the k, we eliminate all the vertical and horizontal part of this one, so we are left with these four. And first we do the AD part. So if you multiply this one, here we have x square, but the other one is going to be 0 because we have 2yz, there's no x. So this part is going to be 0, but when you take the partial derivative of x square with respect to x, that's going to be just 2x, right? And if in the other side we are going to have partial derivative with respect to y of 2xy, and 2x is a constant, y is going to become 1, so 2x multiplied by 1, that's going to be just 2x, right? So this is our cross product. Now from this one you can already see we are getting 0i minus 0j minus plus 0k. Okay, so this is just a 0. So it means this is a conservative vector field. If it's not 0, it's non-conservative, but here we are having 0, therefore the given vector field is a conservative vector field. and that's how we do this kind of problems. I hope this helps. Thanks for watching.